Hey,
How are you today?
good. How about yourself?
Good.
That's good.
Okay, let's see. We left off with this problem, I think. So
Yes.
let's do number 12. Now, number 12 is a tough problem, and it may not be evident to you what to do. I don't know. It might be. Do you have any thoughts?
Um,
First thing we should probably do is draw an approximation of where these points are. We know where that point is. 418, we'll call it that 4 comma 18.
yeah.
1 comma A. Is 1 comma A below or above 2 comma B?
Below.
Okay. So 1 comma A we'll just say is there, and 2 comma B we'll say is there. And that gets the order correct. We know that B is above A because they've told us this is a straight line. So now what? They've asked us about this crazy thing over here, 3 halves B minus A. Now, right offhand, why would they be asking about that? Well, I don't know, but what do we know here? When you don't know what to do on a problem, start doing what you do know how to do.
Okay.
What can you do on this problem?
Um,
What do I know about this line and this line?
they should be equal.
They have the same slope.
Right, same slope.
So same slope. Well, so now what? We know a little bit about slope.
Yeah.
What's the slope of this part of the line from here to here? What's the formula for slope?
Y equals mx plus b.
No, that's the formula for a straight line, but that's not the slope. M is the slope part of that. When you say
Right.
y equals mx plus b, this equation could be put into that, but this is the part that we know something about. We don't know the equation of this line, and that's going to be hard to come up with the equation of this line. But we do know something about slope, do we not?
Yeah.
What's the slope of this part of the line? What's the definition of slope?
Um, the number of units up into the whatever side, up or down into the side, up the y, I mean the
Right.
x and y axis.
If you remember it as just 2 words, you'll always be able to figure it out. It's
Okay.
rise over run.
Oh yeah, rise over run.
So in this case, between these 2 points, let's label them C, B. Let's not do that. I'll confuse the issue. Between these 2 points, what's the slope?
2 over
What's the
x.
rise?
Rise is 2.
No, that's the run. This is the x-coordinate. Remember, the rise is the change in the y-coordinates. In other words, the official definition of slope is y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. But you don't have to memorize that. If you just remember it as rise over run, you can recreate the rise. The rise is the difference in the y-coordinates. I could also say slope is equal to delta y, which is the change in y, over the change in x. So what is slope here?
No, wait.
Start with the bigger one, so we don't have to deal with negative numbers. What's the change in y?
Well, why wouldn't it be 2? Because you're going from 2b to 418. You're going up 2 steps.
But here's the y coordinate.
Oh.
So the change in y is 18 minus b.
Oh, okay. Sorry, yeah, okay, I get it.
What's the change in x? Because that goes in the denominator.
That's 2.
Okay.
Yeah, I mixed it up. Sorry.
Okay, so now what's the slope of this part of the line?
That part of the line is b minus a and 1.
B minus a over 1.
Yes.
Okay. What do I know about these two slopes? If this whole thing is a straight line, what can I say about these two slopes?
That a... Wait.
That's equal to that, right? It's the same slope. In other words, the slope of the upper part of the line is the same as the slope of the lower part of the line. On a straight line, the slope never changes. Once you've got the slope, it applies no matter where you're at on the line. So this m I've written is the same m, which means I can equate that to this. Okay? So I'm going to say 18 minus b over 2 is equal to b minus a over 1, or just b minus a. All right. So now I have something that I know. I know that. I still don't know what it is, but let's go ahead and solve this equation and see what we've got. So what's the first step I want to do to solve this? I should say simplify it. Let's try to simplify this equation.
So divided by 2.
Multiply both sides by 2.
Right.
Hold on. So it leaves 18 minus b on the left, and it leaves 2b minus 2a on the right.
Right. And
now,
then you would add...
They've asked, what is 3 halves... Okay, go ahead. Continue.
We would then add b
to
both sides, and then add 2a.
Well, now hold on. You see how we get to this part, right?
Right.
Okay, and here's what they asked about. They asked about 3 halves b minus a. Well, they want to know what that is. I don't have that in this equation, but I do have something that looks kind of similar to it. What do I have to do to this right side of the equation to turn it into this 3 halves b minus a?
B minus A.
I want to turn it into this. I want to make this over here look like this. What do I have to do to it to make it look like that?
Divided by 2.
Okay, I can do that as long as I divide the left side of the equation by 2. I'm going to turn my camera off. It's hollering at me that I'm overloaded.
Yeah, your voice was separate from the camera.
Okay. All right. Well, I'll definitely turn it off then. So if I divide both sides by 2, now this over here becomes exactly what they're asking about, and it's equal to 9.
Right. Okay.
Okay. This is a very important problem. Even though it was hard, it's all about slope. And slope is really big on this test. You want to know your slope. You want to know its rise over run. You want to recognize instantly how to calculate it. There are a lot of problems where you need to figure out slope. In fact,
How many
slope,
questions do they have about slope? Just wondering.
well, I don't know. We'll run into them. I just know that as long as I've been tutoring, I run into a lot of questions about slope. And
All right.
part of the reason is that when you go on to higher mathematics like calculus, slope is a key fundamental understanding to calculus.
Okay.
It's all about slope. So you're just getting started with slope. You're going to be dealing with it for a while, at least as long as you're taking math. All right.
Okay.
They also like sequences, questions about sequences, arithmetic sums and geometric sums and things like that. So let's look at 13.
Is there a sequence above it? I can't see it.
No. Oh, maybe there? I don't think there is. Oh, yes, there is. Excuse me. Sorry. My gosh.
It's okay. I know I was reading it and I know a sentence
We
above.
both would have been struggling with that because I would have been trying to figure out how to do it. But they kind of explain. They kind of explain how to do it here. These are the first three terms of the sequence.
Yeah.
Okay. And as they say, the first term is 4. Each even-numbered term, well, this is the second term, right? And
Yeah.
this is the third term, and this is the fourth term. So the even-numbered terms are found by multiplying the previous term by -1, so we get -4. Each odd-numbered term is found by adding 3 to the previous term. So if we add 3 to -4, we get -1. Okay? So that's all that all says, is that's how they get this sequence. Actually, we would have been able to figure it out fairly easily.
Yeah.
What is the 37th term of the sequence?
Oh, God. Okay.
Obviously, there's no way we have time to write out the first 37 terms of this sequence.
Right.
So we have to see if there's some sort of repetition that might take place. Well, let's figure out the fourth term. What's the fourth term going to
be? 2.
Each even-numbered term is found by multiplying the previous term by -1. What's -1 times -1?
Oh, I thought it was odd number. Well, that's the third term, and 3 is an odd number, so wouldn't that be the odd number term?
No. Each even-numbered term, and we're looking at term number 4, so it's an even-numbered term.
Okay.
Found by multiplying the previous term by -1. So the previous term is -1. I'm going to multiply it by -1, so I'm going to get 1.
Right. Okay, sorry.
Okay.
I thought I meant like the term itself.
It's okay. Now let's look at the fifth term, because so far we don't have any repetition going on. Well, the fifth term is an odd term, so we need to add 3 to the previous term. Bingo. We found our repetition. Right. Now, at this point, you could spend some time figuring out the sixth term and figuring out that it is going to be -4, but you really don't need to. This looked like a repeating series from the get-go based on their question as to what the 37th term is. We wouldn't be able to answer it if it wasn't a repeating sequence. So we now know that it repeats every 4 times. So what's the 36th term?
So if it takes 1, 2, 3, 4 terms, and then on the 5th term it repeats itself, we do 36 divided by 4 to get 9. So now we just have to count 9. figure out what the ninth term is?
Well, not quite. Not
Do I have
quite.
the...
Let's think about this a little bit more. I know you can figure this out, so I don't want to give you the answer too quick. So here's our repeating sequence. And so on and so
Well, I
on.
mean, there's 9 different...
Okay.
There's 9 repeating terms.
So what's the 36th term?
Would be the last one, because it's 9, it should
I
be
haven't
1.
written it, but that's the 4th term. That's the 8th term. The 12th term is also going to be 1. The 16th term is going to be 1. So what's the 36th term going to be?
1.
Okay. What's the 37th term?
4.
All right. That's the way you deal with sequences. All right, let's see here. Let me see everything now. In the xy plane, the equation of line L is y equal 3x plus 2. So we know the slope, we know the intercept. Let's just go ahead and graph it, because almost certainly we're going to need to do that.
All right.
Notice that I don't take time to be very specific. I know what a slope of 1 looks like, and I know a slope of 3 is steeper. So I just draw a line that's steeper than 1. So there's my line. If line M is the reflection of line L in the y-axis, what is the equation of line M? Now, you know how to do reflections, right?
Right, you just switch it over.
Well, if a point is right there, it's now going to be there. If a point was right there, it's now going to be there. In other words, it's going to be perfectly symmetrical.
Right.
Obviously, that point's going to stay the same.
Right.
So the slope of that is what? If the slope of this is 3, what's the slope of this other line?
It's going to be -3.
Yeah, exactly. So what's the equation of that other line?
A.
Yes. Again, a question about slope. Okay, let me bring up another page here. We want after 281. Hold on. $282. Okay. Number 15.
All right, so she's in here from 5.
Now this is a question that when you look at this, you know you got to get this, right? In other words, you know how to do this. So this is one of those questions that you spend as much time as you need to make sure you get it right, because this is a gift question. Okay. So year 6, what was the height?
It was 25 feet.
Year 9?
100.
What's the percentage increase when you go from 25 to 100?
75.
Actually not.
Boy.
What's the amount of increase? 75. 75 feet is how much it grew, but what's the percentage increase? What are we going to put that over to figure out the percentage increase?
25 over 20 or over 100?
No, 75 over 25. In other words, the tree grew 75 feet, and it started at 25 feet. So this represents the percentage increase.
Oh, okay.
That's 300%.
Oh, okay.
Whenever they ask about percentage increase or decrease, you always look to the starting value to come up with your answer. If I go from 20 to 80, excuse me, if I go from 20 to 100, what's my percentage increase?
400.
Yes. If I go from 100 to 80, what is my percentage decrease?
20?
Correct. In other words, take the amount of movement and always divide it by the starting one, not the ending.
Right.
Never the ending one. They will never ask that question unless they're, I don't know, they could word an algebra word problem, I guess, to ask that question. But in general,
Yeah.
all changes as percents are based on the beginning number. Wow. We are getting some hard ones. Actually not. This may not be as hard as I remember. I looked at this problem for a while. Okay, which of the following has the same volume as the cylinder shown above with radius pi x and height 2x? Well, first of all, let me bring up page 1, which shows us the formula for that volume. Or do you know it?
Well, I have a question just like Esmond. Wouldn't this be kind of like the same with like a rectangle? Like,
Well,
we're talking about volume, so a cylinder with the radius of 2x and the height of pi x would be the same, right? So number A.
not necessarily, because
Kind of like a rectangle,
you
like
figure
the
out the
base.
volume of this thing, one of these dimensions gets squared before we do anything with it.
Right.
Remember, the volume of a cylinder is the area of the base times the height.
Right.
So this volume is what? What's the area of the base? What's the area of a circle?
Pi x squared.
Pi r squared.
Pi r squared.
What's the circumference of a circle?
Pi r times 2.
2
pi r.
Okay. So the volume of a cylinder is the area of the base. So what's the area of the base? What's R?
Sorry, say that again?
What's R? We know the area of the base is pi r squared, so what's R?
X.
No, it's pi x. That's showing us the radius of that thing.
Right.
Okay, so it's r squared, so it's pi x, quantity squared, times pi. And let me put the pi in front. There's pi r squared right there. Okay, you with me?
Yeah.
Times the height, times 2x. So there's our volume. Now, we need to kind of distribute that a little bit. Let's figure out what we're looking at here. Well, this squared only squares these two times pi, so we really are going to have pi cubed x squared, right? Times 2x times 2x, so actually there's a 2 and it becomes that. So our volume, I have simplified it to 2 pi cubed x cubed.
Right.
All right? So now we need to figure out which of these has that same volume. Well, let's see if we can eliminate stuff. Does D work?
No.
Because we get the 2, we get the x cubed, but we only end up with pi squared.
Right.
Does E, and I start with D and E because we know how to figure out the volumes of rectangular bricks real easy. We just multiply the 3 numbers. Does E work?
Yes.
Bingo, we're done. We don't even need to do the hard work of these 2 cylinders here. This cube's pretty easy. This cube would be 8 pi cubed x cubed, not 3, or not 2.
You there?
I'm still here. Can you hear me?
Oh, yeah, there we go. Okay, we're good.
Let me close out other stuff. I wonder if I got stuff running in here. Let me close out this. That'll help a little bit. This
Yeah, I closed out my stuff.
GoToMeeting is so it's a horsepower hog.
Yeah.
So you really want to make sure you don't have anything else open. All right, let's look at 17. So, I mean, it's important to realize that 16, the key ingredient was figuring out the volume of the cylinder we were looking at.
Right, and then figuring out the total equation.
Exactly, and then simplifying it to this, and then back solving from there. By back solving, I mean once we got this 2 pi cubed x cubed, figure out which of those things equals that.
Right.
All right. So 17.
Okay,
Understand what they mean by the question. They want to see if we can solve for this. Can you?
No, you would have to use the same variables, so the answer.
No, we got that variable right here. Why can't we solve for that?
Because we don't have A and C?
Well, they want it solved for in terms of A and C. In other words, all of our answers have A and C in it. So all we have to do is isolate B plus 1, and we're going to have our answer.
Right.
Okay, what's the first step in isolating B plus 1?
Minus 3A.
Okay. What's the next step?
Minus 3.
Not
No,
minus.
oh, sorry. Divided by 3.
Okay. So there's our answer. Now let's see if we've got that on the thing. Well, we don't have it directly. What did they do? They separated this into 2 fractions. What 2 fractions does this separate into? This expression right here can be broken apart into 2 fractions. What are they?
C over E and...
C over 3.
All right, C over 3, sorry, and negative 9A.
Where are you getting 9 from?
Oh, I don't know why I said 9. Negative 1A.
Right.
So it'd be B.
Exactly.
Okay.
Okay. And notice what we did not want to do here. The first natural step to do would be to distribute this 3. If you didn't really know what they're, the mistake that people are going to make here is if you distribute that 3, there's no way you're ever going to get to that answer. So we want to make sure we don't distribute it because we realize we're trying to solve for that. So just treat that like any other variable. In other words, call that Z, and they want to know what Z is. Well, I can solve for Z in the same way we did. We solved for B plus 1. But you have to know this trick that that breaks up into that fraction plus that fraction. Key point. A over A plus B is equal, A plus B over C is equal to A over C plus B over C. Okay?
Okay.
A over B plus C is not equal to A over B plus A over C. Do you see the difference?
Right. Yeah, I understood
This
it,
one
yeah.
has two terms in the denominator. You can therefore not split it into this. This one only has one term in the denominator, so you can split it into these two things.
Right.
Okay? All right. You'll notice that almost all of these tougher problems, they're all two-step problems. In other words, we were able to solve for b plus 1, but we didn't see that answer on there. So we needed to change the answer into something that looked like what they were putting up. Okay. Now, in general, would you say that the SAT is harder or easier than the ACT?
I feel like it's going to be harder.
Based on these problems. But I'm
Yeah.
assuring you that it's not that much harder. We're just running into a string of problems here that are all difficult. However,
The English
go ahead.
the English on the SAT is easier though than the ACT.
Okay.
Because based off the tests at least.
I'm not sure that the math is harder. For one thing, the SAT does not have any trig, doesn't have any conic sections. So on average, I would say they're about the same. But the ACT just has a broader spectrum. They have more easy questions and they have more tough questions. Whereas the SAT tends to have more middle of the road.
In between stuff.
Yeah. Okay, so they're telling us that this shaded region is bounded by the x-axis, the y-axis, the line y equals 3, that horizontal line, and this graph, which is some function that we don't know. Okay, all they're saying is that there is a point that's in the shaded region, and when they say MN, that means the x-coordinate is M and the y-coordinate is N. So that coordinates are M and N.
And then.
Right. And they're saying that point is in the shaded region. It's not outside. It's not in the white area. It's in this shaded region. So does M have to be less than or equal to 3? Oh, and they've labeled the lower part of this. This point here is 4. Does M have to be less than or equal to 3?
Yes.
What about if I put the point right here? What's the M coordinate there? Almost 4, right?
Right.
Okay. So M does not have to be less than or equal to 3.
No. Right. Okay, I get it
If I
now.
put the point over here, yes, M is definitely less than 3. But I can put it in a place right next to the bottom here where it's definitely not less than 3. So I is not true. I is false. Let's examine the second one. does n have to be greater than or equal to m? Experiment with placing points in this shaded region. If I use this point over here, m is definitely greater than n, right?
Right.
But if I use a point right here, m is less than n. So I got lots of variation here where I can put my points. So 2 is not true either.
So that only leaves B.
Well, because there's no none. You're right. And instead of spending the time to figure out what the heck this is going to mean, we don't need to. They gave us a break by not putting none on there. And that's what you want to do. You did right by looking at the answers before, because a lot of people would just plow right through this and then they'd try to figure out what this means, number 3. But you notice that they couldn't all be false, so B has to be true. Good.
Right.
I'm not even sure what 3 means. I'm not sure I've ever considered it because I've always gotten to that point and stopped. All right, let's see. The next page is 283. Okay. Read that. Let's look on 19. And this is a real-life problem. This is exactly the way lumber companies work.
All right. Let's see. A lumber company produces. Okay.
Might not be clear. Which one is it?
Yeah, it's a little confusing.
Well, what is A saying?
That x minus 13
is equal to 1/16, the absolute value of that.
Right.
So x can be within 1/16 of 13, and that's exactly what it is. In other words, x can be anything from 12 and 15/16 to 13 and 1/16. Just like if you go to a lumber yard and you buy a 13-inch board, you're going to get something in between these. You won't necessarily get one that's exactly 13 inches. It's got a plus or minus clearance of 1/16. And what that means is that the length of the board minus 13, the absolute value of that. Notice that when x is 12 and 15/16, this ends up being minus 1/16. When x,
that's why it's the absolute value.
Well, hold on. I'm actually, we're getting its absolute value, because if x was 13 and 1/16, then this would also be 1/16. In other words, either way, this thing is 1/16.
Right.
But notice that these boards are cut between that value and that value. They're not all 12 and 15/16 or 13 and 1/16. They're between.
So it couldn't be equal.
So it's not usually going to be equal, because a board might be exactly 13 inches, in which case it wouldn't be equal to 1/16. So are we looking for an equality sign here, or are we looking for a greater than or equal sign?
A greater than or equal.
A greater than sign, or less, I'm sorry, a greater than or less than sign.
A less than, wouldn't it? Yeah.
Okay.
Less than.
So what's the answer?
C.
That says it's greater than.
Oh, sorry. It would be E.
E. E
'Cause
is
if you
what's
added it,
yes, exactly.
yeah.
In other
Okay.
words, no matter what x is, this is always going to be less than 1/16. Notice that they can't actually, you don't get a board that's 12 and 15/16. It says it's between those two values. So you're never going to get one that's exactly that value or exactly that value, hence the less than sign and not less than or equal to. But they didn't even put the less than and equal to up there, so we know that it's got to be E. That's kind of a tough one, but just requires some thought. These are the last two problems in this section, so they're both going to be tough. Now, this one's kind of a cute problem, and I've seen this repeatedly on a lot of tests. So if you kind of remember this technique, it'll be very helpful. There's a good likelihood you'll run into a problem similar to this. If the first integer, or the smallest integer, is minus 30, what's the next integer in a set of consecutive even integers?
An integer was what again? Sorry.
The least, there's a set of consecutive even integers, and the first term of that list is minus 30. What's the next term?
What's an integer?
They're even. Integers are whole numbers.
Oh, okay.
And you know what even and odd is.
Yeah. Okay, and even integer should be negative 28.
Exactly. The next one?
Negative 26.
Okay. And they're saying that I got a number of these in the set, and then if I add them all up, in other words, this one plus this one plus this one plus this one, I get 66. How many integers are in that set? I've only written 3 of them. Let me give you a clue as to how to solve this. If I started with minus 4 and I listed consecutive integers, sometimes the way to solve these problems is to do it on a smaller scale. What's the sum of these numbers at this point?
0.
Aha. Therein lies the trick.
Well, so you would, to cancel out the negative,
Okay.
you have to go back up to 30. So,
Okay, so
the
I got
integers
30.
from...
So when I get to this point, the sum of all of them is 0.
Right.
So they're saying the sum has to be 66, so how much further do I have to go?
2 more? 3 more. 2 more.
2 more. These 2 are going to add to 66.
Right, so there's...
Now, how many integers do I have? Without listing all of them out, can we figure out how many do we have?
a lot.
No, they don't have that as an answer. So
You'd have 30.
that would be funny. I would love to see a test that had a lot on it. It's almost as good as cannot be determined. I've always told people that the answer is never, it cannot be determined. And I had a tutoring session today on SAT, and I found a question that was the answer.
No way.
Yep. Way.
Wow.
I know. I had to check it twice. In fact, that was that was SAT. It might have been ACT. But anyway. So how many integers do we have left of 0?
2.
Oh, we got minus 30, minus 28, minus 26, minus 24. We got to get to 0 before we can start counting up positive.
You got 15 on the... Oh, so we have 33. Because from negative 30 to negative 2 is 15, and then 2 to negative 2 to 30 is 15, and then 32, and then 34, and 0 are the other three.
Good. Counting 0 is the key. Always
Right.
count 0, because it would be very easy to think we had 15 plus these 2. But notice that they give you a break and that they do not put that answer on the test.
Right.
If you made that mistake, you would look over here and you'd see that you've made a mistake, which is helpful because it allows you to go back and rethink it. Now, you didn't make that mistake, but a lot of people would. They would not count 0. They would count 15 plus 2 and then try to figure out where they've made the mistake. So the answer is 33. All right, let's go to the next section, which is going to be back to easier problems. 284. Whoops, or 291 rather. Now, I was going to bring this up to show you this formula for the volume of a right cylinder. Notice it's pi r squared times h. It's the area of the base times the height.
Oh, okay.
Okay. All right. How about number 1?
All right.
3 over x plus x equals 7 plus 3 over 7. Now, it's definitely worth looking at the answers, but this is probably not one you want to back solve. Notice how hard it would be to back solve. If we start substituting 1/7 for x, then we're going to have to add a huge fraction here and compare it to that fraction. So this is not a good back solving one, just because it's hard to do the arithmetic. So let's look at this for a moment. What is similar? What is similar between these two things?
They both have a fraction, or x and the 7s are in the same spots.
Aha.
So it would be 1 because...
No.
No. Huh?
In other words, if I rearrange the right side, I get 3/7 plus 7. Just by trying.
Oh, it would be 7 because it would make sense.
Exactly. In other words, if I look at the problem like this, now clearly x is 7. But the key is to know that you can rearrange that to make it look just like that. It doesn't look just like that when you look at it. And one of the reasons you answered 1/7 is because you were thinking it must be the reciprocal.
Right.
But if you rearrange this so that it looks as close to the left as possible, you instantly see that the x is replaced by the 7. Okay, figure not drawn to scale. But it's a right triangle because of that.
Let's see.
B is 5. They want to know what
so
it is.
be, what is that called? The,
Pythagorean theorem.
There we go. My mind went blank. I'm sorry. Pythagorean theorem. So it'd be...
You don't need to know the name of it, but you need to know how to solve any side of a right triangle when they give you the other two sides.
So it'd be 25 squared, which is, 5 squared, which is 25,
Okay.
minus 2 squared, which is 4, equals 21. So the square root of 21, it might be...
That's correct. You got it right. Square root of 21 is the answer. That's D.
Right.
Let's go through it, because I want you to be faster than that. First of all, let me draw a standard one here, where everything's labeled with letters. What do we know about this triangle? We know that B squared is is equal to what?
B. Alright, sorry. C squared is equal to 4.
Well, this triangle over here.
Oh, okay. That is 25.
A squared plus B squared. I want to talk general.
It doesn't actually mean like C as in.
I want to talk general terms. Ignore this example for a moment.
Okay.
Okay, notice that C is therefore the square root of A squared plus B squared.
Okay.
That's the easy one. That's not what they gave us, though. They gave us the hypotenuse, and they gave us one of the sides. So if I were to solve for A squared, it would be C squared minus B squared. And then if I want to solve for A is going to be the square root of C squared minus B squared, right? And by the same reasoning, B would be the square root of C squared minus A squared. So here's the key three formulas. When they give you two sides of a right triangle, notice that every one of them start out with square root. So the first words that should come to your mind, or out loud if you were explaining it to somebody, are square root. It doesn't matter whether I'm solving for C, A, or B, the answer is going to be the square root of something. If I'm solving for the hypotenuse, it's the square root of the sum of the other two sides. If I'm solving for one of the sides, it's the square root of the hypotenuse squared minus the other side squared. Both these last two are the same. They're both the square root of the hypotenuse squared minus the other side squared.
Right. Okay.
So in this case here, you want to instantly know that A is going to be the square root of the hypotenuse squared minus the other side squared. And you want to be able to do that quick. You don't want to have to spend 30 seconds figuring this out and then solving for C, A, and B. Just always know how to solve for a third side. Let me give you some examples and see how fast you can do them. Because there's probably no other thing that's as important as the Pythagorean theorem on these tests. You get tons and tons of questions about the Pythagorean theorem. So the faster you can do it, the better. Tell me what C is. And in fact, tell me every step. C is the square root of what?
It is the square root of 3 squared plus 4 squared.
Okay.
Let's see.
Tell me what A is.
A is 9.
No. I want you to give me every
No.
step. Tell me A. Remember, it always starts out with square root.
A equals the square root of 3 and 5.
No, it's the hypotenuse squared minus the other side squared.
A equals square root of 5 minus 5 squared minus 3 squared.
There you go. Okay? That's the key. When you're solving for a side, it's always going to be the square. Everything's always going to be the square root. What is B equal to?
B would be square root of 5 squared minus 4 squared.
Okay. Good. That's how you want to approach right triangle problems.
Right.
You don't want to have to be finding yourself trying to solve that for C, A, or B. That's just a lot of unnecessary math. You want to go straight to the final step, which is C is the hypotenuse, is the square root of the sum of the others, and any of the others is the square root of the hypotenuse squared minus the other squared. So you're always subtracting when you're calculating one side, and you're always adding when you're calculating a hypotenuse.
Right.
Okay. Let's call it a session with that problem.
All right.
Number 2. And we pick up. It looks like you got quite a few sessions scheduled here. I guess they're all in a row because I'm going out of town on Thursday. So your mom wanted to get in as many as she could. So I have you again tomorrow night at 5:30?
Yes.
And Tuesday night at 5:30?
Yes.
And that's it. Okay. And then do you take your test this Saturday that I'm out of town, or a week from Saturday?
It's the week from Saturday.
Must be, because she
2
scheduled.
weeks from Saturday.
Right, because she scheduled another one on the Tuesday after I get back. Okay, and then another one on the Thursday. So you do, and then another one on that Saturday morning. Wow. Okay. So you got a lot.
We're trying to get all the SAT stuff done.
It's going to be worth it, Joel. I know it's a pain for you to have to spend this much extra time on it, but first of all, your fundamental math skills are going to skyrocket, and your score is going to really reflect the work you're putting in here. If we put in another 5 or 6 hours work before you take this test, you're going to be in good shape to take it, I think.
All right.
Okay?
Well, sweet. Cool.
All right. Talk to you tomorrow night.
All right. All right. Have a good night.
You too.